Hello and welcome to this video tutorial on Cobb-Douglas production function. Cobb-Douglas production function is a special type of production function and is very important and interesting topic of macroeconomics. First of all, what is production function? Production function shows the quantitative relationship between inputs and output. Now, Cobb-Douglas production function developed by Charles Cobb and Paul Douglas in 1927 is based upon empirical findings that the share of capital and labor in the total output of the advanced economies remained almost constant. So this is the basis of Cobb-Douglas production function. Remember, Cobb-Douglas production function is not based on any economic study or engineering study. It is based on statistical analysis. Now, production function can be of two types, short run and long run. In the short run, all the factors are not variable. Some factors are fixed and some factors are variable. So in the short run, we get returned to the factor or law of variable proportion. That is, one factor is varied and other factors are kept fixed. But in the long run, all the factors are variable. There is no fixed factor because the firm can change anything. The firm can change the capital, the firm can change the management, and of course the raw materials and other utilities. So in the long run, all the factors are variable. There is no fixed factor. And Cobb-Douglas production function is related to long run production function, not short run production function. Now here it is the production function, that is mathematical representation of the relationship between capital, labor and quantity. Q is the amount of output, K is amount of capital, L is amount of labor, A is factor productivity or you can call it technology, alpha is output elasticity of capital, and 1 minus alpha is output elasticity of labor. Now let me explain what is output elasticity. Output elasticity of a factor means proportionate change in quantity of output as a result of proportionate change in the factor. So output elasticity of capital means how much the quantity of output changes in response to change in capital. In the same way, output elasticity of labor means how the output responds to change in the amount of labor. A and alpha are assumed constant and alpha is greater than 0 and less than 1. Okay. Now I shall explain the characteristics of Cobb-Douglas production function one by one. Number one, if any of the inputs is 0, then output is also 0. Let us see how it happens. If K is 0, then Q equals to A into 0 to the power alpha A to the power 1 minus alpha equals to 0, because anything multiplied by 0 is 0. Similarly, if L is equal to 0, then Q equals to A K to the power alpha 0 to the power 1 minus alpha equals to 0. Again, anything multiplied by 0 is 0. Hence, if one input is 0, then output is 0. This is characteristic number 1. What is characteristic number 2? The production function is homogeneous of degree 1. What is meant by homogeneous of degree 1? This means if inputs are increased by say beta times, then output will also increase by beta times. Let us see how it happens. If inputs, that is capital and labor, are increased by beta times, then Q becomes A into K into beta to the power alpha, L into beta to the power alpha. We have simply multiplied capital and labor by beta. So this is equal to A K to the power alpha, beta to the power alpha. So this is 1 minus alpha. A into beta to the power 1 minus alpha. So it is A K to the power alpha, beta to the power alpha into L to the power 1 minus alpha into beta to the power 1 minus alpha. This is equal to A K to the power alpha, L to the power 1 minus alpha, beta to the power alpha plus 1 minus alpha. This is equal to A K to the power alpha, L to the power 1 minus alpha is what? This is Q. So this is equal to Q into beta to the power alpha plus 1 minus alpha. Plus alpha minus alpha cross out each other. So remains beta to the power 1 equals to Q into beta equals to beta Q. Thus we can see that Q is multiplied by beta. That means when inputs are increased by beta times, output also increases by beta times. Correct? So this proves Cobb-Douglas production function is homogeneous of degree 1. Number 3, marginal productivities, MPs means marginal productivities of capital and labor depends upon the input ratio. Marginal productivities of capital and labor depend upon the input ratios. That means if input ratios are kept fixed, then the marginal productivities will also remain constant. Let us see how it happens. How can we get marginal productivities of capital and labor? By differentiating Q, that is by taking partial derivative of Q with respect to K and L. Now MPK, that is marginal productivity of K, equals to del Q del K equals to, we are taking partial derivative of q with respect to k. So this becomes a alpha k to the power alpha minus 1 into L to the power 1 minus alpha, right? We have differentiated q with respect to k, and we have got what? We have got dq dk is equal to a alpha k to the power alpha minus 1 into L to the power 1 minus alpha. So this is equal to a alpha k to the power alpha minus 1 into L to the power minus alpha minus 1. Here it is 1 minus alpha, so you have taken minus within bracket alpha minus 1. So this gives again minus alpha plus 1. So this is equal to a alpha k to the power alpha minus 1 divided by L to the power alpha minus 1. So this is equal to what? This is a alpha k by L to the power alpha minus 1. Now k by L is the input ratio. So this proves that marginal productivity of capital MPK, marginal productivity of capital, depends upon input ratio k by L. Since A and alpha are constant, A and alpha are assumed constant. Therefore, if k by L remains constant, then marginal productivity of capital will also remain constant. Similarly, MPL, that is marginal productivity of labor, is equal to dq dl. Again we take partial derivative of q with respect to L. So what we get? We get a k to the power alpha 1 minus alpha L to the power 1 minus alpha minus 1, right? So this is equal to a k to the power alpha 1 minus alpha into L to the power 1 minus alpha minus 1. So plus 1 minus 1 cross out each other. So remains L to the power minus alpha. This is equal to what? A 1 minus alpha, A into 1 minus alpha into k to the power alpha divided by L to the power minus alpha means 1 by L to the power alpha. So this is k to the power alpha divided by L to the power alpha. So this is equal to A into 1 minus alpha. Now k to the power alpha divided by L to the power alpha is equal to k by L to the power alpha. Again we find input ratio. Right? So since A and alpha are assumed constant, if the input ratio is kept constant, then marginal productivity of labor will also remain constant. So we have proved these two characteristics of Cobb-Douglas production function. Now I am coming to characteristic number 3, but before that we have to erase this part because I need space. So I am erasing characteristic 1 and characteristic 2. Okay. Yeah. I have erased the explanation of characteristic 1 and 2. Now what is characteristic 3? the expansion path is a straight line. What is expansion path? This is expansion path. This is isoquants IQ1, IQ2, IQ3. We measure labor on x-axis and capital on y-axis. IQ1, IQ2 and IQ3 are isoquants. These are the input combinations. This is L1, this is K1, this is L2, this is K2, this is L3 and this is K3. These are the input functions. So we get these points on isoquants, and if we add this point, join these points, we get the expansion path. Now in case of Cobb-Douglas production function, since it is homogeneous of degree 1, that is, if inputs are increased by beta times, then output will also increase by beta times. Then suppose this is 50, this is 100, this is 200, right? IQ1, IQ2 and IQ3. 50 means 50 units, 100 units and 200 units, the output level. For 50 units, OL1 is the amount of labor, OK1 is the amount of capital. When output is increased twice, 50 is becoming 100, then the input combinations are OL1 and OK2. Hence, in Cobb-Douglas production function, OL2 equals to 2 into OL1 and OK2 equals to 2 into OK1. Why? Because it is homogeneous of degree 1. Inputs are increased by 2 times, so that output is also increased by 2 times. Right? So this is the expansion path, and we have to prove that the expansion path in Cobb-Douglas production function is a straight line. So I am using this diagram. Now what is the equation of the expansion path? The equation of expansion path is given by M1 by M2 equals to R1 by R2. The expansion path is given by M1 by M2 equals to R1 by R2, where M1 equals to marginal productivity of capital, M2 equals to marginal productivity of labor, R1 equals to price of capital, that is cost of capital, and R2 equals to price of labor, that is wage rate. M1 by M2 equals to R1 by R2, and M1 and M2 are marginal productivity of capital and marginal productivity of labor respectively. So again we take partial derivatives of Q with respect to K and L. M1 equals to del Q by del K is equal to A alpha into k to the power alpha minus 1 into L to the power 1 minus alpha, right? And M2 equals to dq by dl, sorry, del q by del L equals to, again we take partial derivative of q with respect to L, so del q del L is equal to a k to the power alpha 1 minus alpha L to the power 1 minus alpha minus 1 equals to a k to the power alpha 1 minus alpha L to the power 1 minus alpha minus 1. So it becomes L to the power minus alpha. So this is a k to the power alpha 1 minus alpha into 1 by L to the power alpha equals to a into 1 minus alpha k to the power alpha by L to the power alpha. Okay. Therefore, M1 by M2 equals to, what is M1? A alpha k to the power alpha minus 1 into L to the power 1 minus alpha divided by A into 1 minus alpha k to the power alpha divided by L to the power alpha. This is equal to R1 by R2. So what remains? I am writing here to utilize the space fully. Remains alpha by 1 minus alpha k to the power alpha minus 1 L to the power 1 minus alpha divided by k to the power alpha by, sorry, this is k to the power alpha, k to the power alpha divided by L to the power alpha. This is equal to R1 by R2, right? So this is equal to alpha by 1 minus alpha into k to the power alpha minus 1 L to the power 1 minus alpha k to the power minus alpha and L to the power alpha, because k to the power alpha divided by L to the power alpha means k to the power alpha into L to the power 1 minus alpha. So we have transferred it to the numerator, it becomes L to the power alpha, that is equal to R1 by R2. So this is equal to alpha by 1 minus alpha. Now k to the power alpha minus 1 minus alpha. So alpha plus alpha minus alpha cross out each other, and L to the power 1 minus alpha into L to the power alpha, again plus alpha minus alpha cross out each other. So remain k to the power minus 1 and into L to the power 1 is equal to R1 by R2. This is equal to alpha by 1 minus alpha L to the power 1 divided by K to the power 1. K to the power minus 1 means 1 by K to the power 1. So we have transferred from numerator to denominator by changing the negative sign to positive. This is equal to R1 by R2, right? Now this is equal to what? Alpha into L into R2 equals to 1 minus alpha into K into R1. So just cross multiply it. Therefore, L equals to 1 minus alpha divided by 1 minus alpha into K into R1 divided by alpha R2 or L equals to K 1 minus alpha divided by alpha into R1 by R2. Now this is a straight line. This equation is an equation of straight line. Why? If you compare this with the standard equation of straight line, that is y equals to mx plus c. Here a equals to k into this plus 0. That means in this function a equals to k into 1 minus alpha by alpha into r1 by r2. If you compare this with the standard straight line equation, so here c is 0. C is 0 means the expansion path originates from 0. There is no positive or negative intercept. Y equals to ms plus c means there is positive intercept on the y-axis. C, this is c. But in this case, there is no positive intercept because the expansion path is starting from 0. Right? So, as we compare this equation, L equals to k into 1 minus alpha by alpha into r1 by r2 with standard straight line equation y equals to mx plus c, it is proved that this is a straight line. This equation is an equation of straight line. This is equation of straight line originating from 0. So the expansion path is a straight line. So I have explained all the three characteristics of Cobb-Douglas production function. This is very important and very interesting topic of macroeconomics. I think it is well understood by you. In another video, I shall discuss what are the assumptions of Cobb-Douglas production function and what are the drawbacks of Cobb-Douglas production function. Right? Now, you see, this production function is homogeneous of degree 1. That is, alpha plus 1 minus alpha is 1. Now let me tell you one thing. we can have the returns by the output elasticity of K and L. How? I am explaining. Before that, I have to erase this explanation of third characteristic. Okay, so I am erasing this one. Suppose we write the Cobb-Douglas function as Q equals to A K to the power alpha L to the power beta, where alpha plus beta equals to 1. That is, alpha plus beta equals to 1 is happening in Cobb-Douglas production function. Now what will happen if alpha plus beta is greater than 1 or alpha plus beta is less than 1? Let us see what happens. First, if alpha plus beta is greater than 1, suppose inputs are increased 2 times, then Q becomes A into K into 2 to the power alpha into L into 2 L into 2 to the power beta equals to A K to the power alpha 2 to the power alpha L to the power beta 2 to the power beta equals to A K to the power alpha L to the power beta is Q. So Q into 2 to the power alpha into 2 to the power beta equals to Q into 2 to the power alpha plus beta. Right? Now watch very carefully. If alpha plus beta is equal to 1, if alpha plus beta is equal to 1, then Q equals to Q into 2 to the power 1, because alpha plus beta is equal to 1. So Q becomes Q into 2 to the power 1, that is 2Q. This means when inputs are increased 2 times, output is increasing by 2 times. Now suppose alpha plus beta is greater than 1. If say alpha plus beta is equal to 2, instead of 1 we take 2, that is more than 1, greater than 1. Then what happens? Then Q becomes Q into 2 to the power 2, because alpha plus beta equals to 2. This is Q into 4, that is 4Q. Here it was 2Q, here it is 4Q. Here when inputs are increased by 2 times, output is also increasing by 2 times. Here when inputs are increased by 2 times, output increases by 4 times, because alpha plus beta is greater than 1 and it is equals to 2. If alpha plus beta is less than 1, say alpha plus beta is equal to 1.5, suppose. sorry, 0.5. Alpha plus beta is less than 1. Here it was greater than 1. Here alpha plus beta is less than 1. Say it is 0.5. Then what will happen? Then Q will become what? Q into 2 to the power 0.5, because alpha plus beta is 0.5. So Q will become Q into 2 to the power 0.5. I mean, when inputs are increased by 2 times, output becomes Q into 2 to the power 0.5. Now 2 to the power 0.5 is certainly less than 2. That means when inputs are increased by 2 times, output is increasing by less than 2 times, because alpha plus beta is less than 1. So the value of alpha plus beta gives us the return, whether it is increasing return, decreasing return, or constant return. In case of Cobb-Douglas production function, we write CD in short. CD production function, it is constant return to scale. Constant returns to scale. Remember, to scale, not to factor, because all the factors are variable. The whole scale of the business is changing. In CD, that is Cobb-Douglas production function, constant returns to scale applies. That is what I drew a few minutes back. This is expansion path. This is IQ1, IQ2 and IQ3. If inputs are increased 2 times, output is also increasing by 2 times. Say 50, 100 and 200. This is L1, this is L2, this is K1, this is K2, this is L3, this is K3. So OL2 equals to 2 into OL1, OK2 equals to 2 into OK1. This is constant return to scale, which is pertinent in Cobb-Douglas production function, right? So far so good. In the next part, I shall explain what are the assumptions of Cobb-Douglas production function and what are the limitations of Cobb-Douglas production functions. The limitations of Cobb-Douglas production function mainly relate to the assumptions. The unrealistic assumptions of Cobb-Douglas production function have led to its criticism. Not in this video, I shall discuss those in another video, right? And I think this is enough for this video. I hope you have enjoyed this video. I mean to say, the video has benefited you. If you think so, please do share this video to your friends so that they can also get benefit by watching this video. And also I would request you to like and subscribe my channel. Okay, and finally thank you for watching this video. Goodbye and stay well.